Hello everyone, this is CM Dinesh, Assistant Professor, Department of Mechanical Engineering. Let deals with Theory of Machines, Unit 3. The balancing of reciprocating mass. The balancing of reciprocating mass. In this image, we can consist of line of strokes which is having in the crank slaughter mechanism. The first one is the introduction of balancing of motion. The various forces acting on the reciprocating part of an engine. The resultants of all the forces acting on the body of the engine due to inertia force only is known as unbalanced force or shaking force. While you you can travel in the car, on the time you can decelerate the car will be most some of the distance because of the already given force. That moment is called, that motion is that matter is called inertia. In that inertia, the force will be very unbalanced. So that type of unbalanced force can be balanced by using some of the techniques which is followed in this chapter. Let's FR, the force required to accelerate the reciprocating part, the FR, it's an initial force. And then Fi, the inertia force due to reciprocating motion. For the accelerating force, we can decelerate the engines. On the time the force happened in the engine is called inertia force. And then Fn, the force on the side of the cylinder wall or normal face acting on the cross head guide. And then finally Fb, force acting on the crank shaft bearing on or main bearing. These are all the force which is acting on the engine. Since Fr and F1 are equal to the magnitude but opposite in a direction, therefore they balance each other. The horizontal component of Fb, force acting along the line of the reciprocating, is also equivalent to Fi. This force Fu is unbalanced force or shaking force required to proper balance. The effect of reciprocating part is used to produce a shaking force and a shaking couple. Since the shaking force and the shaking couple vary in magnitude direction during the engine cycle, therefore the causes very objectional vibration. And we can see the primary and secondary unbalanced force of a reciprocating engine. Let's see the M is the mass of the reciprocating part, and L is the length of the connecting rod PC, and R is the radius of the crank OC. And the angle which is mentioned in the crank and the line of stroke is theta. We can have the angle, and finally by the rotating element we can have the angular speed of the crank, omega. Omega is nothing but 2 pi nd by 60. And N is a ratio of the length of the connecting rod to the crank radius L by R. The accelerating of the reciprocating is alpha R is omega R square cos theta plus cos 2 theta plus N. The cos theta is a primarily balanced, cos 2 theta by N is a secondary unbalanced force which is acting on the cylinder. Therefore, the inertia to the reciprocating part or a force required to accelerating the reciprocating part is MAR is equal to, we can add the mass and the mass in the same equation. MAR is equal to M omega square plus cos theta plus cos 2 theta by Dn. These are all the force which is required for primary and secondary force which is acting on the engine. These can be carried out. Omega R cos theta is a primary unbalanced force. Mass omega R square by cos 2 theta by N is a secondary force acting on the cos square. By solving these equations, we can narrow down the formula. We can finally have these two forces we can easily unbalanced by using this formula in the unbalanced reciprocating mass problem. Thank you for watching this video. Thank you. Bye. Have a queries, just call me. This is CM Dinesh, Assistant Professor, KSR College of Engineering, Department of Mechanical Engineering. Thank you.